Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Today, I will deliver my lecture on type of metamorphism. I will cover this topic in two parts. In this lecture, I will proceed under the following heads: Introduction, type of metamorphism, classification based on the principal metamorphic agents, classification based on geological setting, IUGS SCMR recommendations, and contact metamorphism. Hope it will be useful for you. Try to be regular in course. On the basis of principal agent of metamorphism and field relations, the metamorphic types can understood in terms of thermal T, dynamic P, or combination of these two, dynamothermal P and T. The type of metamorphism, a classification scheme for recommendation have been based on the principal agent of metamorphism, thermal, dynamic or dynamothermal. Second, B, the geological setting of the metamorphism, contact, cataclastic or regional. C, the orogenic setting of the metamorphism, orogenic or anorogenic. And D, the plate tectonic setting, plate margin or plate interior. Classification based on the principal metamorphic agent, temperature and pressure are the two principal factors that affect metamorphism. This observation has led to the classification of metamorphism in three types. First, thermal metamorphism results when temperature is the dominant agent. A, contact metamorphism is an example of thermometamorphism. B, pyrometamorphism. C, caustic metamorphism. And D, pneumatolytic metamorphism. Second, dynamic metamorphism result when pressure is the dominant agent, either lithostatic pressure or diabatic stress. First, cataclastic metamorphism is one example of dynamic metamorphism that occur locally along the fault zone as the result of differential stress. B, burial metamorphism occur on a regional scale as a result of loading in a relatively static environment. Third, dynamothermal metamorphism results from both thermal and pressure effects, and in general they are the following types. A, the type of metamorphism generally occur on the regional scale in orogenic belts along convergent plate margins. B, orogenic metamorphism. C, ocean floor metamorphism. Classification based on geological setting. Geologic setting is quite commonly used as a classification scheme because the geological context is often quite apparent and there is a genetic relationship between the metamorphic types and the agent of metamorphism. There are four general categories: contact, shock, cataclastic, and regional. Following the IUGS SCMR recommendations, we shall use the following classification. First, contact metamorphism. A, pyrometamorphism. Second, regional metamorphism. Orogenic metamorphism, burial metamorphism, and C, ocean floor metamorphism. Third, hydrothermal metamorphism. Fourth, fault zone metamorphism. And fifth, impact or shock metamorphism. On the basis of principal agent of metamorphism and field relation, the metamorphic types can understood in terms of thermal, temperature, or low pressure, high temperature metamorphism. This is also a part of local metamorphism or thermal metamorphism or Buchan type metamorphism, or even we can know as Abukama type of metamorphism. Contact metamorphism occur in the vicinity of an igneous intrusive as the result of thermal and sometimes metasomatic effect of the hot magma. Pressure commonly ranges from 200 to 2000 bars, that is depth of burial less than 8 km, and temperature varies from 400 to 800 degrees centigrade or even higher. When a magma intrudes colder region, the adjacent rocks are heated. The large temperature gradient 100 degrees centigrade per kilometer or more is decreasing from the hot intrusive contact to outer zones or areoles of thermal metamorphism. The thermal effect around an intrusives are seen in the development of new minerals such that high temperature minerals will develop near contact and low temperature mineral towards an outer fringe or pass outward with decreasing metamorphic grade. The width of zone of each metamorphic grade is increased with 1. Increasing temperature of magma. The temperature of granitic intrusive is 650 to 700 degrees centigrade, syenitic magma 900 degrees centigrade, and gabbroic magma about 1200 degrees centigrade. Second, increasing thickness or diameter of intrusion. And third, C, increasing depth of intrusion. When depth of intrusion is more, temperature increase 100 to 150 degrees centigrade due to geothermal gradient. The texture of thermally metamorphosed rock is hornfelsic and lack of schistosity. Contact metamorphism take place in areoles surrounding intrusive rocks at relatively lower temperature as compared to pyrometamorphism. Argillaceous rocks in contact metamorphism is recrystallized to rocks known as hornfels containing cordierite, andalusite, etc. Similarly, impure limestone are recrystallized to calcareous hornfels containing wollastonite, grassolerite, diapsite, and plagioclase, etc. Contact metamorphism is primarily a thermal phenomena and considering considerable mass transfer and vapor phase or fluid flow may also occur. This vapor phase or volatile fluid phase may escape from the intrusive along fractures in the country rocks or infiltrates the country rocks along grains boundaries. Due to infiltration, the metasomatism take place into a limestone country rock. A scron is produced. Fluids emanating from granitic intrusive may also carry metals which deposited as an ore. These fluids also change the isotopic composition of the country rocks as well as the bulk chemical composition. Contact metamorphism occurred in diverse tectonic setting due to dynamic process. It may occur wherever any igneous activities occurs, in orogenic or anorogenic environments, or in plate interior or along plate margins. The best developed contact areoles are in anorogenic plate interior where granitic intrudes sedimentary rocks, and best Indian example is wollastonite deposit, Rajasthan. Usually contact areoles are localized in the vicinity of the igneous intrusive in active orogenic belts. However, intrusive rocks may be sufficiently numerous and closely spaced and overlaps the one another. The net result is to increase the temperature of an region by the heat into crust by magma. This is known as regional contact metamorphism and in many areas is responsible for low pressure and high temperature condition of metamorphism. The best Indian example is Khetri Copper Belt, Rajasthan by Lal and Sukla 1975. Pyrometamorphism. It includes the intensive local changes at very high temperature more than 800 degrees centigrade, affecting xenolith, increase in basic lavas or near the surface where pressure is considerably low, pressure less than 500 bars. Impure limestone developed minerals like spurite, larnite, etc. In peltic rocks, andalusite is transferred to mullite and quartz to higher temperature polymorph tidamite. Such metamorphic condition correspond to the cyanidinite phases. The term neometallurgic metamorphism is used when material is removed or introduced through media of gas or vapor. If the media is hydrothermal, solution is called hydrothermal metamorphism. Neometallurgic metamorphism. In normal contact metamorphism, little or no change in bulk composition of the rock is involved. But in some cases, the magmatic immersions and removal of material from the country rocks is so evident that their composition is considerably altered when the introduction or removal of material is through media of vapors and gases. It is called neometallurgic metamorphism. Water and boron vapor are concentrated in the residual liquids towards the end of the crystallization periods of the granite. Thus, already solidified parts of the granite feldspar are partially replaced by the tourmaline. With the formation of tourmaline, granite or scroll rocks, the process is known as tourmalinization. Similarly, heated steam causes kaolinization. The feldspar are changed to kaolinite or china clay. Caustic or ophthalmic metamorphism. This includes indurating burning effect produced by lavas or small dikes on the Gondwana coal seams. The coal seams are intruded by lamprophire around which the coal devolatilized and converted into coke-like rocks known as jhama. Dear student, today in this lecture we have discussed about the type of metamorphism part 1. I have covered this topic under the following heads: introduction, type of metamorphism, classification based on principal metamorphic agents, classification based on geological setting, IUGS SCMR recommendations, and contact metamorphism. I believe this lecture was useful for you. In my next lecture, I will cover regional metamorphism. For further studies, please read the textbook, references, and links given in the text.